This discussion will introduce the quotient rule of differentiation. If a function is defined as a ratio of two differentiable functions, where the denominator function is non-zero, then the derivative is defined in this way. We have the denominator function times the derivative of the numerator function minus the numerator function times the derivative of the denominator function, all over the denominator function being squared. Some calculus students learned a little mnemonic device that goes something like, they call this the high function and this the low function, and they say low d high, d standing for derivative, so derivative of high, minus high d low, all over the square of what's below. Once again, that's low d high minus high d low, all over the square of what's below. But let's use the quotient rule with a specific example. Suppose we had the function y equals x squared plus 3 over 5x plus 1. And we wanted to find the derivative of y. Well, using the quotient rule and using maybe our mnemonic device, we would take low, which is the low function, 5x plus 1, d high, so the derivative of the numerator function, the high function, which is x squared plus 3, and we'll take the derivative of that on our next step. So we have low times the derivative of the high minus high function, x squared plus 3, times the derivative of the low function, 5x plus 1, all over the square of what's below. So 5x plus 1 being squared. Okay? On our next step, we'll actually take the derivative. You notice we didn't perform the differentiation here nor here, so we will do that now. This is 5x plus 1 times the differentiation of x squared plus 3 is 2x. Minus x squared plus 3 times 5 over the square of what's below, 5x plus 1 squared. We'll prettify this a little bit, but we're already pretty much at the answer, but we will simplify and see if there's a way to reduce the fraction. We'll distribute the 2x, we'll distribute the 5, we'll also distribute the negative. We have to be very careful with the quotient rule because of the negative. Lots of students mess up that sign, but making our distribution, we have 10x squared plus 2x, and then a negative 5x squared minus 15, because we're not only distributing the 5 across this binomial, but also the negative, all over 5x plus 1 being squared. And then finally, we see the numerator, 10x squared minus 5x squared is 5x squared, and then plus 2x minus 15 over 5x plus 1 squared.